Hello, my name is Devashish Parekh and this is a video presentation on automated highway systems which is in fulfillment of a midterm report on the very same subject. This presentation will correspond to a PDF report that has been submitted as well. This presentation aims to provide an overview of my project on automated highway systems. In this presentation, I will be talking about the background, the history of roadways, the history and inception of automated highway systems, or AHS as I would be referring to it in the rest of the presentation. We are going to talk about why do we need AHS, what is the concept of ITS, Intelligent Transport System, and what it entails. What is the concept of connected vehicles, what are its advantages, what exactly is AHS and what is its definition, so on and so forth. So let's begin. Let's first take a look at the history of roadways. Well, mobility is a basic requirement and old roadways were part of all ancient civilizations. Earlier human beings were moving for food, shelter, and very trivial just for survival, etc. Now the scene has changed and now the world major economies rely on mobility. Products, people, and services they need to move from place to place. And just from a historical perspective, if we look at the history of roadways, how important roadways were for human beings, we just have to look at Roman Empire. Roman Empire itself had more than 400,000 kilometers of road, and out of that, more than 80,000 kilometers of it was stone paved roads. So we can say pretty confidently that we understood the importance of roadways pretty early on. But now the scenario has changed a little bit. Now it's not just enough to move from point A to point B. Moving from point A to point B has now taken an economical flavor to it. Economics flavor to be more precise. So let's just take a look at the condition of roadways in the United States at right now. Currently, there are more than 9 million miles of road in the United States, and more than 267 million vehicles are on these roads. Congestion, accident, incidents of various and all sorts are part and parcel of modern day life in modern day societies. We can say that these are the bane of existence in modern day cities. And because of this humongous pressure on the infrastructure, current infrastructure development techniques are insufficient to cope with modern day problems of transportation. So why do we need better infrastructure? Well, with rapidly changing technology, our roadways have reached far corners of the world. And traditional stone paved roadways are not a part of, do not serve our purposes today. So traditional roadway problems have also changed. Congestion is due to various reasons. It could be due to climate, extreme weather conditions, whether if you go higher up to higher altitudes, there is snowfall, there are landslides, accidents, roads under construction, various other reasons. And rapid advancements in fields of communication, sensors, etc. It has allowed us to make better and better vehicles. It has changed the way we move. And automated vehicles have also enabled us to look at driving cars from a completely new perspective. All these changes have completely transformed the way we move from point A to point B, and this has changed our infrastructure as well. So we need to keep up with the technology, with the vehicles, the rate the vehicles have changed. We have to keep up with, we have to keep the same pace of improvement in infrastructure as well. Now, we can look at, we know why we need better infrastructure. So now let's look at what are some of the what are the ways we can improve our infrastructure. One very simple solution would be to just increase the number of lanes on our current infrastructure, which would definitely allow more traffic on the road. It definitely would solve the problem of congestion. But even if we talk about this solution, the thing is, this solution made sense just a few decades ago. It doesn't make any sense right now because the resources that would be put into it would just outweigh the just solving one problem of congestion. Not to mention problems of global warming, civil rights in favor of land acquisition to make more lanes simply outweighs the benefits of making more lanes. Moreover, vehicles and traffics are going to keep increasing, so it's not just worth the effort to increase the lanes that we have. So what do we do? How do we increase? Well, one of the popular solutions is automation. It has been shown and proved in various studies that if we remove the human error element from driving, we can significantly reduce many problems like congestion, pollution, accidents, and incidents. Well, some people like to say that just repeating the what I've said in other words, the human element. How about if we just enhance the intelligence of driver through technology? He would be able to make better decisions. So either we go completely or towards automation or partial towards automation. We have to start thinking about that right now. And the answer, the solution automation provides us is ITS and AHS. So what is ITS and AHS? ITS stands for Intelligent Transportation Solutions or Systems. It is an umbrella term for all new tech that is aimed at integrating technological advancement or intelligence with the intelligence of the driver of the vehicle. And AHS is the longest range component of ITS. It aims at redefining the traditional driver-vehicle relation to a new driver-vehicle infrastructure experience. We have added the infrastructure bit to it. We'll discuss it later on. Um, well, let's talk about the history of AHS for a little while. The history of AHS is that officially it can be traced. The inception of AHS can be traced to 1939 New York World Fair exhibit Futurama. It was designed by Norman Bell Geddes, an industrial designer who was commissioned by General Motors to design the exhibit. He envisioned lanes for traffic on both sides completely isolated from each other. Traffic would be subdivided into towns and cities, and speed limits were introduced for the first time. In Geddes' own words in his book Magic Motorways, he describes Futurama as a large-scale model representing almost every type of terrain in America and illustrating how a motorway system may be laid down over the entire country, across mountains, over rivers and lakes, through cities and past towns, never deviating from a direct course, and always adhering to the four basic principles of highway design: safety, comfort, speed, and economy. So that is how Mr. Norman Bell Geddes thought of AHS. So just keeping up with that, ISTEA, which stands for Intermodal Surface Transportation Efficiency Act, was passed by the United States government in United States Congress in 1991 with a budget of $650 million. And the aim of this bill was to develop AHS and automated vehicles. ISTEA called upon Department of Transport to investigate the idea of AHS, which in turn established NAHSC, National Automated Highway Systems Consortium, to implement the idea of AHS in 1994. And the Department of Transportation set up a deadline of 1997 for NAHC to develop a prototype by 1997. Let's take a look at what connected vehicles are. We have seen that automation is the key. So actually it's very important to mention here that there is a difference between connected vehicles and automated vehicles. Automated vehicles just use sensors and all the other tech to maneuver on themselves. There is no information or input exchange in between two vehicles. That lies under the gamut of connected vehicles. The aim of connected vehicle is to use various wireless technologies to provide information exchange capabilities to vehicles. And we can do that via three technologies. V2V, which stands for vehicle to vehicle connectivity. V2I is vehicle to infrastructure connectivity, which we mentioned earlier. V2X is vehicle to anything, vehicle to mobile phones, tablets, smart watches, anything else. Let's talk a little bit about these technologies in a little bit of detail. V2V, as I've said before, ability that is given to vehicles to talk to each other. It aims at giving 360-degree awareness to the position of other vehicles. Right now we are talking about 300 feet, but some studies and some research is trying to give this connectivity to up to 1 kilometer. Dedicated short-range communication technology is used to achieve this V2V connectivity that we are aiming at. 75 megahertz bandwidth in the 5.9 gigahertz band will be used, and IEEE 802.1 protocol will be used. Very similar to V2V is the V2I connectivity. Vehicle to infrastructure communication, as it is called. It also uses DSRC technology, supports sensing of environment even for vehicles that do not have latest sensing technology. It is used for more precise navigation. So one example of V2I would be the vehicle that is connected with the infrastructure that would be built specifically for it. V2X is vehicle to anything other than vehicles and infrastructure. Vehicle to mobile phone, tablets also use DSRC communication technology. Can also be used to communicate with pedestrians and other devices capable of communication. And all these three, as I mentioned, are used to relieve traffic congestion. So what exactly is AHS if we look at the formal definition of AHS aims at creating separate dedicated lanes for automated vehicles. There would be which would move in tight formations in those dedicated lanes, and they would communicate with each other. So what are the challenges? Let's take a look at the implementation of AHS. Biggest challenge is the implementation of technology. We have so much technology here that we need to implement, but how and when is the question of it. AHS, as I've mentioned in the formal definition, requires dedicated lanes. Huge investment is required, and with this huge investment, we know that not everybody would be able to afford vehicles equipped with automation technology. Since dedicated lanes are required, special entry and exit points for automated vehicles will be needed, which may result in choke points, which may just overweigh the advantages of AHS. One of the major urban design challenges will be for mixing of automated and unautomated traffic, and it will definitely be a challenge to design such sort of dedicated lanes. Building new roads and adding rights of way will be problematic in urban areas. Alternative system configuration will be required for urban and suburban rural settings. Incidents on automated roads may cause serious operational disruptions requiring timely incident detection and removal. Otherwise, these all are going to add up time. New jurisdictional organization and cooperative mechanisms will be required to operate and maintain automated facilities. There would be a need to make queuing for vehicles entering an automatic facilities. New laws, new provisions would need to be made for that. One of the most important challenges is that we will need to check vehicles into automated environment while they are in motion. Not just normal emergency or exit checkout systems. Provisions need to be put in place. If somebody needs to get out of the automated environment suddenly due to some emergency, we have to make provisions for that as well. That's a challenge in itself. Vehicle and driver readiness need to be verified before handling the control back at the exit points. EHS designers must keep in mind that some motorists travel on freeways for a short distance and small times. Their entry and exit point on EHS is critical to their benefit. So information that would be provided to them at that point of time also needs to be weighed. Uh, Talking about technology, by 2020 it is assumed that more than 200 sensors will be on vehicles. And these 200 sensors need to be able to perform under adverse weather conditions for successful operation of AHS. Adding these automation capabilities may reduce vehicle reliability, which would increase the cost of preventive vehicle maintenance. So these are some of the challenges that I have found up till now in the implementation of AHS. Now let's take a look at AHS from the perspective of system engineer, and why do we need system engineering in AHS at all? Well, just on a cursory glance, we can see that the system of AHS consists of at least two subsystems. The first is the vehicle part, and the second is the infrastructure that includes roads and sensors and all the other all of that. This vehicle subsystem will actually be moving along on the EHS, and as we have seen in assignment 1 as well, vehicle subsystem can be subdivided into multiple subsystems: sensors, data processing, image processing, actuator, communication equipment, etc. EHS will have several subsystem and components as well: EHS entry, EHS exit, object detection, collision warning and avoidance, longitudinal and lateral vehicle control. And navigation would also be an issue in this case, because as we have seen, we will have to not just make normal entry and exit position, but we have to make exit provisions for emergency situations as well. So it would be a challenge. And with this, I would like to end this video presentation, and I hope it gives some insight into the background and the concept development stage and challenges that we would face in the development of AHS. Thank you.